Alright, we're going to pick back up where we left off last week, you guys. We've been talking about exponent rules. So again, if you can't find your foldable right away, go ahead and take out a sheet of notebook paper and put it on notebook paper, and you can put it into your foldable when you find it when you get home. Alright, so last week we talked about this first rule here, a to the 0 power. Alright. We talked about a negative exponent. We talked about multiplying with the same bases. Remember, the bases were the same. And we talked about raising an exponent to another exponent. So next, we're going to talk about raising a product where the bases are different to a power. So last week we were doing some kind of pre-examples to see if we could kind of figure the rule out first. And so that's what I'm going to do. So on the left side, on that gray side, let's do an example. Let's see here. What if I had like, I don't know, let's do x, y cubed. X, y cubed. Well, that means whatever's in my parentheses, how many times? 3 times. So I have x, y times x, y times x, y. Well, because I'm multiplying, I could rewrite this so that my like terms are next to each other, yes? So I have x times x times x times y times y times y. Well, then I have x how many times? 3. So that's x cubed. And then I multiplied y how many times? 3. Bless you. So I could rewrite that as x cubed, y cubed. So one way to kind of think about that is what we're kind of doing is we're kind of distributing that exponent. We're kind of distributing that exponent, right?
Kind of like multiplying it and dividing it.
A little bit. So let's write the rule. So my rule is AB to the nth power equals A to the nth, B to the nth. Beautiful. Let's do a few examples. Let's say 3x squared (2m cubed) and rs to the 11th power. We're going to rewrite these as positive exponents. You ready? right, so in my first example, in example A, I'm going to square the 3, and I'm going to square the x. So that's going to be 3 squared x squared. Okay. Beautiful, because we can simplify that 3 squared. 9x squared. Beautiful. All right, what about B?
6
Well, hold on. So that's going to be 2 cubed and m cubed. So 2 cubed, 2 times 2 is 4. 4 times 2 is 8. It's going to be 8. Careful. Those 2's can be tricky. So we're not multiplying the base times the exponent. And then m cubed can't be simplified any further. What about C? Yep, that's an 11. So we're going to have r to the 11th, s to the 11th. Yes, sir. Oh, yes. I can get you a pencil. All right. So that's our exponent with 2 different bases. All right, page 7. Page 7, we kind of played with a problem similar to this on Friday. So let's do a pre-example. So on the left side on that orange sheet, let's write x to the 5th over x squared. Oh, sorry, thank you. Over x squared. We're on page 7, pre-example, so I'm on the left side. Adrian, on the next page. All right, so if I expand x to the 5th, what's that going to look like? What's x to the 5th look like if I expand it?
X times X times X times X times X.
Beautiful. And then x squared expanded looks like x times x, yes?
Yes.
All right. You guys, side conversations need to stop. So I have a question. Good. Are you sure? Or what's x divided by x?
What?
1, right? Think about it. 7 divided by 7 is 1, right? So x divided by x is 1. X divided by x is 1. Have y'all ever done canceling like that when you were dividing? No? Yeah, a little bit? Some of us?
So it's basically X to the third power?
Exactly, because that's all I have left is x to the 3rd power.
I have getting that's how it was done. I just got to punch. That's it.
So what's happening? What's happening to my exponents?
You're taking the bottom two away from the top two.
Beautiful. We're going to take the bottom from the top. We're subtracting. Perfect. So let's write our rule. My rule says, ladies, my rule says a to the m over a to the n is equal a to the m, that numerator, minus n, the denominator. I'm going to do s to the 7th over s to the 5th. P to the 10th over p to the 4th. C to the 4th over C to the 7th. I did. I thought I'd be funny. The first one, s to the 7th over s to the 5th. All right, y'all ready to try these? Are we ready to try these three? All right. So, my rule says that I'm going to subtract the denominator's exponent from the numerator if the bases are the same. So that's something else, you guys. Again, my bases are the same again, right? So in A, are my bases the same? So I'm going to say s to the 7 minus 5th power. So what's 7 minus 5?
2.
So s squared would be my simplified expression. Is that okay? Yes, ma'am.
So we're only subtracting the number.
Just that exponent. Yes. Should I do another example with a number as a base? Maybe? No, it's fine? All right, we'll see, because I've got some practice problems for us to do after our foldable. All right, B. So we're going to have p to the 10 minus 4th power. What's 10 minus 4? P to the 6th. P for piece of cake. P to the 6th. All right, one more. Y'all ready? All right. So I have C, that one's C, to the 4 minus 7th power. Negative 3. Oh, wait. What do I do if I have a negative exponent? So it's over 1, so we could take the reciprocal, right? So 1 over
1 over C cubed.
C cubed. Perfect. 1 over C cubed. All right. Last exponential rule. Last rule. You ready? Here I have A over B to the nth power. So let's do a pre-example again. Another pre-example. Eyes up here, please. I'm going to say x over y cubed. X over y cubed. This is going to be my pre-example. Well, if I'm saying something's cubed, I'm saying I'm multiplying that thing times itself 3 times, right? So this means x over y times x over y times x over y.
I've become so used to using dots as
Multiplication.
symbols that I
Good.
don't even think about it anymore.
Awesome. Well, here if you're multiplying fractions, you just multiply across, right? So I can write this as one fraction that's going to be x times x times x over y times y times y.
So basically, x cubed over y cubed.
Exactly. So this is kind of like the the problem, the rule on page 6, right? All I'm going to do is I'm going to take that exponent, and both the numerator and the denominator get that exponent. Both are going to get that exponent. All right, so my rule. My rule says a over b to the nth power is a to the nth over b to the nth. All right, so my examples.
Oh, number 3 has multiple rules. Number 8 is not.
All right. Side conversations need to stop, you guys. Side conversations need to stop, please. All right. Let's take a look at these 3 examples. Eyes up here, please. Eyes up here, please. So, on A, I have r over p to the 4th power. So I can rewrite this as r to the 4th over p to the 4th. Because both the numerator and the denominator get that exponent, 4. That's it. All right. Example B. I have 2 over m squared, so that's going to be 2 squared over m squared. Well, could I simplify 2 squared a step further? Yeah, 2 squared is 4 over m squared.
Really, you don't have to, right?
You don't have to. No. Ladies, gentlemen, eyes up here, please. Last example.
I think this can have multiple rules involved.
It does. So we've got 3 as my exponent. So my numerator is going to get the 3. So that's a cubed, right?
Over b cubed, c cubed.
Because we have BC that's cubed. You're exactly right. Then we have to distribute that cubed again. So it's a cubed over b cubed, c cubed.
And I just finished doing the rules that 6 rule.
Oh, fantastic.